sense of what you're seeing. Until next time, keep guessing. I want you to imagine, just for a second, that you are texting a 13-year-old kid.
Okay, setting the scene.
Yeah. And his name is Eugene Guzman. He's from Odessa, Ukraine. And he is basically embodying every single stereotype you might expect from a moody teenager who is, being forced to message a total stranger.
Oh, absolutely. So he's sarcastic.
Very sarcastic. He's highly evasive. He's overconfident, maybe a little bit rude. And then suddenly, inexplicably, he's playful.
Right, like a typical teenager.
Exactly. So you ask him a direct question about where he lives, and he completely dodges it. He just throws out this defensive quip instead.
I mean, you know the type. You've probably interacted with teenagers exactly like this, where getting a straight answer feels like, pulling teeth.
It really does. But here is the massive catch. What if I told you that this deeply moody, highly evasive teenager on the other side of the screen isn't a human being at all?
Wait, really?
Yeah. What if you were actually talking to, like, a few thousand lines of Russian code?
I mean, it is the ultimate digital sleight of hand. You sit down at the keyboard, you project a human mind onto the text bubbling up on your screen. But you are really just hitting a reinforced wall of carefully programmed misdirection.
Okay, let's unpack this. Because this Eugene Guzman program didn't just trick a few random people in some obscure chat room.
No, it was a huge deal.
It was. We are pulling from an absolutely fascinating source today, Chapter 13 of a text titled Inference and Language I. And our mission in this deep dive is to rigorously analyze how this specific illusion of artificial intelligence is manufactured.
Right, we're going to break down why genuine language understanding remains really the ultimate unconquered hurdle for computers.
Exactly. And we are going to look at the logical step-by-step failures of these modern big data approaches to AI. Because the Guzman situation, it literally made global history.
It did, and the context of that history matters immensely. So the date was June 7th, 2014. And the setting wasn't some, tech startup basement. It was the highly prestigious Royal Society in London, hosted by the University of Reading.
Wow, so very official.
Very. The event was specifically orchestrated to mark the 60th anniversary of Alan Turing's death. So the atmosphere was thick with the weight of computer science history.
Right.
And at this event, Eugene Guzman reportedly did the impossible. It passed the Turing test.
Which is wild. And for anyone who needs a quick refresher, the Turing test is essentially the gold standard set by Alan Turing back in 1950 at the absolute dawn of computing.
Yeah, his idea was beautifully simple.
It really was.
Yeah.
If a human judge sits down, has a text-based conversation with a machine, and cannot reliably tell it apart from a human being, then, for all practical intents and purposes, the machine must be deemed to have human-level intelligence.
Right. And Guzman managed to convince 33% of the expert judges over a 5-minute text exchange that he was a living, breathing teenage boy.
33%. I mean, the media reaction was nothing short of explosive.
Oh, it was a frenzy.
The press treated this as the crossing of the ultimate technological Rubicon. Time magazine declared that the age of robots is here.
Yeah, the Independent called it a breakthrough and described the program as a supercomputer.
Gizmodo was telling its readers, this is big. The BBC labeled it a world first. It just dominated the news cycle globally.
What's fascinating here is the massive philosophical tension that our source material zeroes in on regarding that exact desire.
What do you mean?
Well, the press reacted with this breathless excitement because it touches on a perennial science fiction dream we all share. We desperately want to converse with our creations.
Right. We want C-3PO. We want HAL 9000.
Exactly. We want the machine to wait up. But there is a vast, unbridgeable canyon between a machine appearing intelligent and a machine actually being intelligent.
Yeah, those are two completely different things.
The public saw a machine passing a conversational test and assumed the machine understood language. But the reality of what happened in London was entirely different.
Because almost immediately after this global celebration, the curtain gets violently pulled back.
Oh, yeah. Experts pushed back hard.
Right. Experts like Gary Marcus, who was at NYU at the time, and Hector Levesque, who was a giant in the field of AI, they stepped up and completely burst the bubble.
They did not mince words.
Not at all. They didn't view Guzman as a breakthrough. They labeled it a parlor trick, a complete fraud.
Right, because the source text points out that Guzman succeeded not by mastering the English language, but by actively, aggressively avoiding language understanding.
Which is such a weird concept. How do you win a conversation test by avoiding conversation?
Well, think of it like this. Guzman was a sophisticated evasion engine. If you ask a complex question that requires a deep comprehension of the physical world or history or logic,
And the machine obviously doesn't know the answer.
right, the machine doesn't have the answer programmed into its database. So it has to do something to cover its tracks. What does it do? It throws a teenage temper
That's
tantrum?
so clever.
It changes the subject entirely. It uses a sarcastic joke to deflect the burden of conversation back onto the human.
There's actually a specific dialogue example from the text that perfectly captures this evasion.
Gary Marcus was actually one of the people testing Gooseman, right?
Okay, he gives it to
And he asked a very straightforward, simple question. He asked, "Do you read The New Yorker?"
a super basic question.
Right. Now, a human would say yes, no, or maybe mention a specific article they liked. But Gooseman's reply was, "I read a lot of books. So many, I don't even know which ones."
I'm just completely dodging it. And think about what is fundamentally missing from that response. There is zero actual comprehension of what the New Yorker is.
Because a magazine is not a book.
Exactly.
Yeah.
But the program doesn't know what a magazine is. It simply pattern matches the word read in Marcus's question, dips into its bag of pre-written deflections regarding reading, and spits out a generic excuse about reading too many books to remember.
Wow.
It relies entirely on the human judge giving it the benefit of the doubt, which we have been doing for a very long time. The text highlights that this is not a new parlor trick. We've actually been falling for this specific flavor of deception since the 1960s.
Oh, yeah, the ELIZA program.
Yes, there was this famous early computer program called ELIZA, created by Joseph Weizenbaum, which was designed to mimic a Rogerian psychotherapist.
And Rogerian therapy is the key here. It is highly non-directive.
What does that mean exactly in practice?
Well, the therapist mostly reflects the patient's own thoughts back at them to encourage them to keep talking. They don't offer specific advice or deep analysis.
Ah, I see.
It is the absolute perfect persona to cloak a dumb machine because the persona inherently refuses to answer questions.
The source gives a classic example of this dynamic, actually.
Yeah.
A human tester types into ELIZA, well, I've been having problems with my husband.
And ELIZA just flips it.
Right. ELIZA immediately spits back, tell me more about your husband. It literally just grabs the noun at the very end of the user's sentence and slaps the phrase, tell me more about, in front of it.
It's essentially Mad Libs.
Exactly. There's no cognitive processing happening there.
None. And it works entirely because of the logic of social contexts. This is a crucial philosophical point in the text. Human expectations dictate our perception of intelligence.
Right. We prime ourselves.
Yeah, when you enter into any conversation, you automatically, subconsciously adopt the social rules of that specific dynamic.
So if you think you are talking to a moody teenager from Ukraine who doesn't care about adult topics and speaks English as a second language, you dramatically lower your expectations for their comprehension.
Exactly. Or if you think you are talking to a hands-off therapist whose explicit job is just to prompt you, you subconsciously excuse them from doing any cognitive heavy lifting.
I see it as handing a student a math test. Like you hand a kid an algebra test and say, solve for X.
Right.
And the student just rolls their eyes, doodles a picture on the paper, and cracks a joke about how algebra is useless because they're going to be a professional gamer.
Typical deflection.
Right. But then the teacher laughs, thinks the kid is charming and highly socialized, and gives them an A+ in calculus.
Which is ridiculous.
We would never accept that in a school. Why on earth do we accept this from artificial intelligence?
Because human beings are biologically wired to be cooperative communicators. We actively want the interaction to make sense.
Oh, that makes sense. We fill in the gaps.
We do. We fill in the conversational blanks. We assume intention where there is absolutely none. But as the text argues, by allowing these cheap conversational tricks, we expose a deep vulnerability in our own psychology.
Right.
We lower the bar for detecting intelligence when our expectations for the dialogue are lowered. And this realization led to a massive, immediate backlash, not just against the Gooseman program, but against Alan Turing's fundamental legacy.
The fallout was brutal. The moment people realized Gooseman was essentially a fraud, tech blogs started claiming that Turing's original test was fundamentally broken.
Yeah, they really threw the baby out with the bathwater.
Gizmodo ran a piece calling the Turing test outdated nonsense. Wired magazine published articles questioning if a casual 5-minute fireside chat is even the right benchmark for full-fledged AI.
Right, the overarching narrative became, if a chatbot can cheat the gold standard test this easily, the test is useless. Let's throw it out.
But the author of our source text, alongside prominent thinkers like Ray Kurzweil, steps into this debate, to fiercely defend Turing.
And they argue the exact opposite of the media narrative. The Turing test itself isn't broken.
Right.
The way we currently administer it is just pathetically lax.
I mean, I need to push back on Kurzweil a bit here. If a piece of software can fake its way through a test in 5 minutes and convince expert judges, how is the test not broken?
Well, Kurzweil's defense rests on a strict logical absolute. He argues that the key to Turing's paper is the converse statement.
Okay, unpack that for me.
Yes, a genuinely intelligent entity might fail the test, say. An alien intelligence that simply doesn't know English. That could happen. But any entity that does pass a legitimate, rigorously administered Turing test genuinely must possess human-level intelligence. You cannot fake a deep, highly technical, hours-long conversation about complex world events using snarky deflections.
Oh, so length is the issue.
Exactly. So his first proposed modification is incredibly simple. Extend the time limit.
Because 5 minutes is a blip.
It's nothing. Make it 2 hours. The cheap tricks will inevitably run out, and the machine's lack of a world model will be brutally exposed.
Okay, I buy that. But the text goes even further than just adding time on the clock, though. It suggests entirely new rules of play.
Yeah, theoretical modifications.
Right, modifications designed to completely strip away the machine's ability to hide behind these specific social personas.
One of the most brilliant suggestions from the text is to enforce strict courtroom rules on the AI.
I love this part.
Imagine administering the Turing test, but before the conversation begins, the machine is metaphorically sworn in to tell the whole truth and nothing but the truth.
So no dodging.
Exactly. The judge explicitly forbids the use of sarcasm, deflection, evasion, or changing the subject.
That is a phenomenal constraint. You completely eliminate the Eliza card. If a lawyer asks, "Where were you on the night of the 14th?"
The witness cannot reply, "Well, tell me more about that night yourself. How did that make you feel?"
The judge would hold them in contempt of court. You're forcing the AI to actually answer the premise of the question.
Or, as another framework, the text suggests treating the Turing test like a high-stakes job interview for a voice-activated personal assistant.
Right, like an interview for Siri or Alexa.
Exactly. In a professional job interview, if you give a flippant, teenage-style answer to a technical question, you fail instantly. You don't get the job.
Because it shows you don't understand the assignment.
Right. By enforcing these rigid, highly formal conversational rules, you bake the requirement of genuine understanding directly into the structure of the test. You immediately neutralize all the cheap tricks.
So if Eugene Gooseman were subjected to courtroom rules, his programming would collapse in 30 seconds. Which proves the underlying mechanism of the Turing test is actually a fantastic metric, provided we don't let the machines cheat the social contract.
Exactly.
But this argument leads to a really interesting pivot in the source material. Open-ended dialogue, even in a courtroom setting, is incredibly messy.
Oh, human language is chaotic.
It is. It is completely saturated with what the text calls pragmatic phenomena.
Right. The unspoken rules, cultural context, tone, implied meaning.
Yeah. So if we are trying to isolate pure language comprehension, what if we just eliminate the back and forth entirely? What if we strip away the conversation and just test an AI's ability to read a single document in a vacuum?
That concept leads us to what the text calls the Turing test monologue.
The monologue test.
It is a deliberate simplification of the original test. Instead of a dynamic, two-way conversation, a human judge simply pastes a block of text, say a daily news article, into the prompt.
Okay.
And then asks the machine highly specific questions that require a deep understanding of what the text actually means.
The specific example given in the text is pasting an Associated Press article titled, "Your Tacos or Your Life?"
Right, a real news story.
And then asking the AI a qualitative question. Like, is this story funny or not, and why?
There are no conversational tricks to hide behind here.
None. No moodiness. Just read this static document and analyze the human experience embedded within it.
From a purely logical standpoint, passing this test is a direct subset of the full Turing test. If you possess human-level intelligence, you should easily be able to read a news story and answer basic analytical questions about it.
It makes sense.
In theory, this should actually give a massive advantage to the machine because it no longer has to navigate the incredibly complex, messy social dynamics of a two-way human conversation. It just has to process data.
But when we actually look at how our most advanced machines perform on this simplified monologue test, the results are a disaster.
A total disaster.
Now, I can already hear people listening to this thinking, hold on, haven't major tech companies like Microsoft and Alibaba built AI systems that explicitly beat human baselines at reading comprehension.
Right, we see those press releases all the time.
Constantly.
Those headlines are incredibly pervasive, and they usually refer to a specific industry benchmark called the Stanford Question Answering Dataset.
Commonly known as SQUAD.
Yes, Squad. The tech media highly celebrated Microsoft and Alibaba for surpassing human baseline scores on this specific test.
Wow.
But our source text completely deconstructs this so-called success, revealing it to be another sophisticated illusion.
Because there is a massive fundamental difference in logic between genuinely comprehending a text and merely underlining words in a text based on a prompt.
Exactly. When researchers looked closely at how these multi-billion-dollar AI systems achieved high scores on Squad, they realized the machines were only succeeding when the complete literal answers were explicitly stated in the text.
So they were cheating again.
In a way, yes. The machines were engaging in high-level pattern matching of explicit cues. The human questions pointed directly to a specific string of words, and the AI just highlighted that statistical string.
So it wasn't reading.
Not at all. It was executing an advanced form of the Control F5 function on a keyboard.
You know, the underlining analogy is perfect here. I remember doing this exact thing in elementary school.
Oh, we all did.
The teacher hands you a worksheet with a paragraph that says, the mitochondria is the powerhouse of the cell. And the question at the bottom asks, what is the powerhouse of the cell?
Right.
As a second grader, you don't need to know what a mitochondria is. You don't need to understand cellular biology. You don't even need to know what a powerhouse is.
No, you just match the words.
Exactly. You visually match the words powerhouse of the cell in the question to the paragraph.
Yeah.
And you underline the word sitting right next to it, mitochondria.
And that is exactly what the AI is doing, just on a scale of millions of parameters.
That's
The definitive proof that this is merely pattern matching without a shred of understanding comes when you ask the AI a slightly implicit question.
right. A question that requires even a tiny leap of logic.
Exactly. The text brings up a fascinating study by Gary Marcus and Ernest Davis highlighting the embarrassing failures of these exact systems. For instance, they fed the AI a short snippet of Super Bowl coverage.
Okay, just a standard sports recap.
Right. Then they asked it what should be a ridiculously simple question for anyone who has ever watched football. They asked, what is the name of the quarterback?
And the state-of-the-art AI failed it.
It utterly failed.
Why?
Because the text might have contained a sentence like, Tom Brady threw a touchdown pass to win the game,
Yeah.
but it might not have explicitly contained the exact, literal phrase, Tom Brady is the quarterback.
Oh, I see.
A human reader seamlessly, unconsciously infers the role of the person from the action of throwing a pass in the context of a football game. We have a world model of how sports work.
Right, we know quarterbacks throw passes.
But the machine, lacking the explicit matchable string of text and possessing zero world model of what a football is completely lost.
So what does this all mean? It means that when we remove the theatrical tricks of dialogue, when we take away the sarcasm, the evasiveness, the ability to play a character,
Right.
and we force the AI to prove it actually comprehends what it's reading, it fails on basic elementary logic. It proves that the Turing test's bar isn't too low, as the tech bloggers claimed. The bar is actually incredibly high, because human language is infinitely complex.
It is a monumental threshold. Extracting facts from a text is far too easily faked by statistical underlining.
Right.
So the entire field of computer science faced a severe dilemma. How do we design a test that forces an AI to prove it possesses basic human-level common sense while entirely removing its ability to cheat by underlining explicit facts or evading the question?
And this brings us to Hector Levesque, and what I consider to be one of the most elegant, mind-bending diagnostic tests in modern computer science.
It's brilliant. In 2013, Levesque presented a seminal paper titled On Our Best Behavior, which essentially became a call to arms for those seeking genuine AI over statistical parlor tricks.
He wanted to push past the big data techniques and test for actual common sense.
Exactly. To do this, he resurrected and formalized a challenge originally posed years earlier by AI pioneer Terry Winograd. Levesque called his version the Winograd Schema Challenge.
And it focuses on a linguistic concept called the pronoun disambiguation problem.
Which is a mouthful.
It is, and I admit it sounds incredibly dry and technical, but it is a cognitive process that every single human being does flawlessly, subconsciously, thousands of times a day. You really need to walk through this step by step because the logic here is absolutely beautiful.
Okay, let's do it. Let's look at Terry Winograd's original test sentence.
Go
Now,
ahead.
the classic sentence is this: the town councilors refused to give the angry demonstrators a permit because they feared violence.
Okay, let's break that down mechanically. Step one is identifying the grammatical ambiguity.
Right. The question Levesque poses to the AI after feeding it that sentence is simply, who feared violence? Is it A, the town councilors, or B, the angry demonstrators?
Well, from a purely grammatical syntactic standpoint, the pronoun they is plural.
Yes.
Therefore, according to the rules of English, it could legally refer to either the town councilors or the angry demonstrators.
Exactly. Grammar alone cannot solve this sentence. A parser looking only at syntax hits a dead end.
But for a human reading that sentence, you don't even pause. You don't experience a moment of confusion. You know instantly that they refers to the town councilors
And why is that?
because of what the text refers to as common sense holism. You cannot just parse the syntax. You have to understand the real-world dynamics of power, protest, bureaucracy, and human behavior.
You know instinctively that town councilors are authority figures who hold the legal power to grant a permit.
Right, and you know that demonstrators are by definition angry outside the system and potentially volatile.
You know that the group in power typically fears violence from an angry mob, and that this specific fear would logically lead them to deny the legal permit.
So you synthesize all this vast, unwritten, real-world knowledge in a fraction of a second to confidently assign the pronoun they to the counselors.
But the machine doesn't have any of that physical or social context. It just sees two plural nouns and one plural pronoun floating in a mathematical void.
It's completely blind to human experience.
Entirely. But here is the true genius of the Winograd schemas, the flip mechanism.
Oh, this is the best part.
Levesque deliberately designs these sentences so that changing just one or two words completely flips the correct answer without changing the grammatical structure of the sentence whatsoever.
Let's look at the Joan and Susan example from the text to illustrate this.
Okay, the first setup sentence is, Joan made sure to thank Susan for all the help she had given.
And the question is, who had given the help? A, Joan, or B, Susan?
Right. And common sense tells us Susan gave the help because social convention dictates that you thank the person who provided assistance to you. So she is Susan.
But now, apply Levesque's flip. We change exactly one word. We change given to received.
Right.
The new sentence is, Joan made sure to thank Susan for all the help she had received. The question remains the same. Who had received the help? A, Joan, or B, Susan?
And now the answer instantly flips to Joan, because you thank someone for the help you received.
It's brilliantly simple, yet infinitely complex for a machine. Let's do another one, the golfer's example, which relies on physical characteristics instead of social rules.
All right, lay it out.
The sentence is, Sam tried to paint a picture of shepherds with sheep, but they ended up looking more like golfers. The question is, who look like golfers? A, the shepherds, or B, the sheep?
Well, a human knows that shepherds are human beings and golfers are human beings.
Right.
Sheep are four-legged animals covered in wool. An amateur painting of a person standing in a field might accidentally look like a golfer holding a club instead of a shepherd holding a staff, but a painting of a sheep wouldn't be mistaken for a human golfer.
Obviously not.
Hmm.
Therefore, common sense dictates that it refers to the shepherds.
I always compare this to looking at an optical illusion. You know those black and white drawings that look like a duck from one angle? But if you shift your focus, it suddenly looks like a rabbit.
Oh yeah, the duck-rabbit illusion.
Exactly. The syntax of these sentences is the drawing. It can technically go either way. But for humans, our vast reservoir of real-world knowledge acts as a lens that locks the correct meaning into place instantly. We don't even see the ambiguity.
But for the AI, the image is constantly shifting back and forth.
Yes. Because they don't have a world model, the text notes that state-of-the-art AI systems score barely above random guessing on these multiple choice questions. It's a coin flip, 50-50.
Now remember the structural beauty of this test. These are multiple choice questions.
Right.
There is absolutely no room for the AI to change the subject, act moody, or make a sarcastic joke about reading too many books. It is forced to choose A or B.
It strips away all the evasion of the Guzman-Turing test and zeroes in entirely on whether the machine has a conceptual model of the physical and social world.
But wait, if I'm a tech billionaire funding a massive AI lab with limitless computing power, my first instinct is just Google it.
That's what they all tried to do.
We have the entirety of human knowledge digitized. Why can't a multi-billion-dollar AI with access to the entire internet just statistically guess its way out of this?
Yeah.
Why can't it just count how many times the word shepherds and the word golfers appear together online versus how often sheep and golfers appear and just pick the highest number?
Because Hector Levesque specifically designed Winograd schemas to be entirely Google-proof.
Okay, that is fascinating.
This is where we hit a critical philosophical wall for big data and machine learning. The text introduces several examples that prove why statistical frequency does not and cannot equal true knowledge.
But how do you mathematically guarantee a sentence is Google-proof? What's the mechanism?
By intentionally combining concepts that rarely, if ever, co-occur on the internet in that specific grammatical context. For instance, Levesque poses this schema: can a crocodile run a steeplechase?
A steeplechase being an obstacle course race for horses or human track athletes, right?
Correct. Now, any human with ordinary baseline common sense knows instantly that a crocodile, with its short, stubby legs, heavy tail, and aquatic nature, cannot run a steeplechase.
No, it'd be terrible at it.
But if an AI tries to answer this by searching its vast, multi-trillion-word database, it hits a solid wall. There are 0 web pages discussing crocodiles running steeplechases.
Because why would there be?
Exactly. The specific combination of those nouns simply doesn't exist in the training data.
Because why would any human being ever write an article or a blog post explicitly stating that a crocodile cannot run a steeplechase?
Yeah.
It's so utterly absurd and self-evident that it is entirely absent from the data.
And without that data to analyze statistically, the machine learning system has no frequency patterns to exploit. It is flying entirely blind. You cannot statistical guess your way to an answer if the baseline data doesn't exist.
That makes perfect sense.
The text brings up another variation from Gary Marcus, actually, testing whether an alligator can jump hurdles.
Okay.
Humans know alligators have short legs and drag their bellies, so the answer is no. But if you change the subject from an alligator to a gazelle, the answer instantly changes to yes, because we know gazelles are agile, long-legged jumpers.
But again, you aren't going to find Wikipedia articles explicitly stating alligators are fundamentally incapable of jumping track and field hurdles, or gazelles are highly capable of clearing track and field hurdles.
Right.
It's just not how human beings record knowledge. We assume the reader knows what legs are. We assume the reader knows gravity exists.
The AI researchers, however, didn't just throw their hands up and give up.
Of course not. There's too much money involved.
They devised a highly sophisticated mathematical counterattack to try and beat the Winograd schemas using big data anyway. They created a trick based on extracting relationships and properties, even for rare noun combinations.
Here's where it gets really interesting. I want to walk through this counterattack very carefully, because understanding this trick is the core of understanding why big data fakes comprehension.
Okay, let's break it down.
Let's use the suitcase example provided in the text. The sentence is, the trophy would not fit in the brown suitcase because it was so small. The question is, what was so small? A, the trophy, or B, the brown suitcase?
Okay, let's look at human common sense first. If object X does not fit into container Y because something is too small, logic dictates it must be the container Y that is too small.
So the suitcase is too small.
Right. But how does an AI solve this without any concept of physical space? The AI researchers programmed the system to break the sentence into quasi-computer-ease logic variables. It extracts a relation, which we will label R, and a property, which we will label P.
I want to make sure I'm following the mechanics here. So in this specific sentence, what is relation R and what is property P?
The relation R is the action does not fit in. The property P is the descriptor, is so small.
Okay, got it.
So the AI takes these two extracted variables and goes out to search the entire web, looking for which noun trophies or suitcases is more frequently associated with the concept of being too small when things don't fit.
Oh, I see the cheat. It doesn't need to find a web page specifically discussing brown suitcases and trophies together.
Exactly.
It just needs to scan millions of social media posts, travel blogs, and retail forums. And statistically, humans complain all the time about their suitcase or backpack or luggage being too small when they're packing for a trip.
Yes,
They
exactly.
almost never complain about a trophy being too small to fit into something.
The machine aggregates the frequencies and says, aha, container-type objects are statistically far more likely to be described as too small in the context of the relation does not fit in. Therefore, the highest probability answer is the brown suitcase. It gets the correct answer without having any conceptualization of physical space, volume, three-dimensional geometry, or what a suitcase actually is.
That feels like a massive, definitive victory for big data. They found a statistical loophole to cheat the uncheatable test.
Mm.
They bypassed the need for a world model entirely.
They thought they did, but Levesque anticipated this exact engineering mindset.
Of course he did.
He had a linguistic countermove ready that completely, utterly demolishes this statistical trick.
What did he do?
He leaves the nouns exactly the same. He leaves the relation R and the property P exactly the same. He simply tweaks the syntax connecting them. The new sentence is, the trophy would not fit in the brown suitcase despite the fact that it was so small.
The question remains the same.
Yep. The question remains, what was so small? A, the trophy, or B, the brown suitcase?
Oh, wow. Despite the fact that
Yeah.
it completely rewrites the physical physics of the sentence. If object X doesn't fit into container Y, despite something being small, then the small thing has to be the object trying to get inside. It's the trophy. The trophy is small, but it still won't fit, maybe because it has a weird, jagged shape.
The logically preferred answer instantly flips to the trophy. But look at what happens to the AI's mathematical trick.
Oh, the math doesn't change.
Exactly. The relation R is still extracted as does not fit in. The property P is still extracted as is so small. If the AI relies on its massive statistical data scrape, it will still confidently choose the suitcase because suitcases are still statistically more associated with the word small online than trophies are.
And the AI will confidently get the question wrong.
Completely wrong.
If we step back and look at the implications here, I mean, this is devastating for the current paradigm of AI development. A minor, completely ordinary syntactic tweak, just adding the phrase "despite the fact," destroys the entire multi-billion-dollar statistical model.
It really does.
It proves beyond a shadow of a doubt that the machine is just tracking word frequency proximity. It has absolutely zero grasp of the physical dimensions of suitcases and trophies. It's just doing high-speed calculus on vocabulary words.
And if we connect this to the bigger picture, as the author points out, the modified sentence using despite the fact is probably far less common online than the original version with because.
So the AI's reliance on big data actually becomes a massive hindrance, not a help.
Exactly. When the sentences get slightly more complex or venture into the less common phrasing of everyday human speech, the statistical house of cards collapses instantly.
That makes total sense.
This is the ultimate rub. Even with incredibly simple one-sentence scenarios, the underlying meanings of words and the physical relationships between everyday objects completely frustrate techniques that rely purely on data without underlying understanding.
It's a profound, persistent illusion. And the text points out that this illusion of good enough results is causing a tremendous amount of confusion among the public, especially in vital areas like automated language translation.
Oh, translation is a huge part of this debate.
Right. We look at tools like Google Translate and we think, look, AI has solved language. I can translate an entire French website into English in 1 second. It works.
We've all done it.
But the source material pulls the rug out from under that assumption too.
The text explicitly tackles automated language translation, which is frequently touted by tech CEOs as the ultimate proof that AI is mastering natural language. But we have to rigorously distinguish between statistical mapping and actual semantic translation.
Right.
The text uses a great historical example regarding Canadian parliamentary documents.
Right. Canada produces vast amounts of official government documents, the Hansards, which are translated perfectly word for word between English and French by expert human linguists.
Because this massive, perfectly aligned, high-quality data set exists on the web, modern deep learning approaches can just indiscriminately ingest it all.
They just eat the data.
Yeah. They rely heavily on inductive statistical strategies to find one-to-one mappings between common English phrases and their French counterparts. If you type a highly common phrase like John met Mary at the cafe into Google Translate, it easily and instantly spits out John a rencontré Mary au café.
This is perfectly acceptable, accurate translation.
It is.
But the crucial point is that it is doing that without knowing who John is, what a cafe is, or what the social act of meeting someone entails.
Not at all.
It just knows, mathematically, that whenever this specific string of English letters appears in the dataset, the specific string of French letters usually appears directly next to it.
And this pure pattern matching strategy works perfectly right up until it encounters ambiguity.
There's always a catch.
The moment you introduce referential phenomena like complex pronouns or polysemy, which is the linguistic term for words that have multiple different meanings depending on context, the statistical machine crashes hard.
This historical context brings us to Yehoshua bar Hillel, a brilliant researcher from the 1960s who figures prominently in the text.
He was way ahead of his time.
He really was.
And
This guy basically saw the future of AI's failures decades before they happened. Back during the Cold War, when people first started trying to automate translation using early statistical computer models to translate Russian into English, Barhill said the entire endeavor was philosophically hopeless. Why? Because of one famous example sentence he created to prove his point.
the sentence is elegantly simple. The box is in the pen.
Now, out of context, I admit that sounds a bit weird, but the word pen is a classic example of a polysemous word.
Right, it has two completely different definitions depending entirely on the context of the sentence.
It can mean a writing instrument,
Hmm.
a pen with ink, or it can mean a small enclosed space for animals, like a pig pen or a child's playpen.
Now, apply baseline human common sense. If I say to you, the box is in the pen, which definition of pen makes physical, geographical sense?
Well, a dox is generally an object larger than a standard writing instrument. You cannot physically put a cardboard box inside an ink pen,
Obviously not.
but you can easily put a box inside a wooden enclosure built for animals. So common sense and the laws of physics dictate that pen in this sentence must mean an enclosure.
But look at what happens when you feed that exact sentence into a statistical translation engine. The text notes a staggering fact.
What is it?
Even as late as October 2020, with all the advances in neural networks and deep learning, if you put the box is in the pen into Google Translate and asked for French, it translated it as La boîte est dans le stylo.
And stylo in French specifically and exclusively means a writing instrument, like a ballpoint pen. The multi-billion-dollar AI confidently chose the wrong physical reality.
This raises an important question about the severe limitations of our current technological trajectory. Why did Google Translate choose stylo?
Because of the math. Right?
Exactly. Because in its vast, multi-billion word database of ingested internet text, the word pen is statistically far more frequently translated as stylo than as enclos, which is the French word for enclosure.
So it just played the odds.
It simply played the mathematical odds, but statistical likelihood is not the same thing as genuine understanding. They aren't even in the same conceptual space.
That phrase from the text, not even in the same conceptual space, is so powerful. It means that simply feeding the machine more data won't ever actually solve the root problem.
No, it won't.
If you have a fundamentally flawed architectural method like guessing, meaning based solely on word frequency, getting faster at guessing doesn't mean you are suddenly understanding. You are just making statistically probable mistakes at a faster rate.
This phenomenon is what experts call the long-tail problem of statistical AI.
The long tail. Okay.
These inductive, data-heavy approaches work remarkably well for the most common, highly frequent phrases sitting right in the center of the bell curve of human language.
Like the cafe example.
Right. But human language is infinitely creative. We constantly invent new sentences, combine concepts in novel ways, and use rare phrasing. That vast expanse is the long tail of the perf.
And what happens in that long tail?
In that long tail where statistical likelihood drops off drastically, the AI gets exponentially worse because it lacks the foundational world knowledge to figure it out from scratch.
So, synthesizing all this, we arrive at the core argument of this deep dive. The author of Chapter 13 is issuing a massive, urgent warning to both developers and the public. We're being blinded by good enough results.
We really are.
Because Google Translate can get the cafe sentence right, and because a program like Eugene Guzman can successfully make a snarky joke to deflect a judge's question, we are aggressively projecting true human intelligence onto machines that are fundamentally just incredibly complex calculators doing high-speed word math.
It is the paradigm of disguised idiocy.
That's a harsh term.
It is, but that is the exact phrase from the text that we must reckon with. The author points out that acceptable accuracy is highly contextual depending on the task.
Give me an example.
In a task like image recognition, if a computer algorithm correctly identifies 80% of the photos of cats, we might reasonably say, wow, that's pretty good progress for a machine. It's an acceptable margin of error for a difficult, subjective, visual task.
But language comprehension isn't just subjective pattern matching. When dealing with a Winograd schema, a sentence as fundamentally simple as the trophy wouldn't fit in the suitcase because it was so small. An average human being scores 100% effortlessly.
Right. There is absolutely zero inherent cognitive difficulty for us.
So if a supercomputer scores 80% on those schemas, meaning it completely misunderstands the basic physical reality of 2 out of every 10 simple sentences it reads, That is not progress.
It's exactly that. Disguised idiocy. The text makes a brilliant, chilling comparison to the mythical androids, the replicants, in the sci-fi thriller Blade Runner.
Oh, I love that movie.
In that fictional universe, the androids look physically perfect, they sound conversational, but eventually, a highly specific psychological test, the Voight-Kampf test, unmasks them as programmed imposters completely lacking genuine human empathy and understanding.
And the Winograd schemas do the exact same thing to our modern AI systems.
They are the Blade Runner test for natural language. It only takes one simple question, requiring basic physical knowledge of a brown suitcase and a plastic trophy, to unmask a multi-billion-dollar algorithm as a completely unthinking machine.
As we wrap up this deep dive, I want to leave you with a final provocative thought to mull over something that stretches beyond the boundaries of the text we've discussed today.
Let's hear it.
We've established that AI is currently failing these Winograd schemas because it lacks a world model. But let's imagine a future, maybe 10 or 20 years from now, where researchers finally figure out how to program that world model.
Okay, assuming they can crack it.
Right. Imagine they build an AI that can perfectly answer every single Winograd schema, understanding the physical difference between suitcases, trophies, sheep, and crocodiles without relying on statistical cheats.
A truly flawless score.
If an AI finally passes that ultimate test of common sense, does that mean it has finally achieved true, conscious understanding? Or does it just mean we spent decades building a slightly more sophisticated, highly complex mirror to fake it even better?
That is the ultimate question.
When the machine finally gets the joke, is it laughing or is it just executing line 4,000 of its code? It's something